What will the future bring? Since the dawn of history, this question has exerted an incredible fascination. We humans have always attempted to unlock the secrets of the future. In our modern world, we rely on experts and scientific opinions to predict what lies ahead. Scientists don't approach the future irrationally or emotionally, but pragmatically, on the basis of data. Nobel Prize winners are particularly respected as authorities because their research in the past has shaped the current state of the world. They are the geniuses of our time. And what better place to hear what Nobel laureates think about the future than Lindau? Let's start with an often discussed theme: population growth. Nobel laureates are certainly among those who worry about the future of humankind. This topic often brings up the name of Thomas Robert Malthus. In 1798, in his essay on the principle of population, the English cleric addressed a question that continues to be hotly debated. When will we no longer be able to feed all the people on Earth? Malthus predicted a number of catastrophes, which fortunately have so far not occurred to the extent he foresaw, but concerns remain.
You've seen that all those that preceded us, my first slide, ended by becoming extinct. The Neanderthals only 35,000 years ago. Why not us? Why not we? Well, that's a good question. But you have to remember that if 10 billion individuals have to go extinct, that's not the same thing as 10,000 in Central Africa. 10 billion all over the world. That means that before we become extinct, the most unimaginable apocalyptic events can take place, fights and epidemics and whatnot. If we let things go, there won't be enough food for everyone. There won't be climates to sustain. There won't be. So we are doomed if we don't do something about it.
Malthus took a pessimistic view. He called for the education of the lower classes and sexual abstinence as ways of limiting population growth. Abstinence may not be popular today, but education and the wealth it creates, says Stephen Chu, could bring the population explosion to an end.
There's light at the end of the tunnel. This is the projection of the population growth depending on three estimated fertility rates around the world. And what it really is saying is the following. By the end of this century, it may be probable or possible that the population will actually peak and decline. Why is this? It's because we've been noticing over the last 2 decades, across all cultures, all religions, everything, the richer you get, the more you go into a middle-class life, you have fewer children. There may be many reasons for this. Education of women, infant mortality goes away or is greatly reduced, late-night TV. Choose your favorite.
Wealth as a form of birth control. Does this mean the problem may solve itself? Next topic, energy, or more precisely fossil fuels. Oil, gas and coal are efficient energy carriers. They can be easily transported and they have a high energy density. Perfect, actually, if they weren't limited and if the global economy weren't so dependent on them. How long will the Earth's fossil fuel supplies last? That's been the subject of many different prognoses. In 1973, physics laureate Dennis Gabor spoke in Lindau about the limited capacity of the Earth. He predicted that even before the turn of the millennium, it would become clear that the idea of enduring wealth, peace and happiness was an illusion. Jack Steinberger gave the world until 2035 to find alternatives to oil, while Robert Laughlin believes that we have until the end of this century. The exact date may be hard to predict, but it is clear that at some point fossil resources will be used up. Most laureates agree that alternatives need to be found to avert the threat of war and unprecedented social upheaval. But even Nobel Prize winners can show a bit of gallows humor given such prospects.
You have seen this morning these ice age cycles in Steve Chu's talk, yeah? And there is some likelihood that we will have another ice age in the not so distant future. And so we have to cope with that also. And then, of course, if we have the same ice ages, then Berlin will be under the ice. And we will not be sitting here because there's a few hundred meters of ice up here.
And that will last for how many years? 100 years?
No, that will last for the next 80, 90,000 years.
80, 90,000 years.
Yes.
Okay, problem solved.
Not a pleasant notion. Happily, there are many more suggestions for solving the energy question. Solar energy collection by satellites in space, nuclear fusion, or electrolysis, for example. At the Lindau meetings, renewable energies have often been discussed as the key to our energy future. Purely numerically, it should be possible to supply the entire world with wind and solar power, apart from the problem that the sun doesn't shine everywhere all the time and that the wind doesn't always blow. Hartmut Michel had the following suggestion.
And in my opinion, electricity supply would be the best if we would have superconducting cables which would connect photovoltaic fields, areas in Arizona, Mexico, in the Sahara, in China, in Australia, and because the sun is shining everywhere. And if we have superconducting cables connecting the fields and supplying electricity to consumers, we would not have to store electricity.
Robert Laughlin took quite a different view.
Why don't we do that? Simply because the line is expensive. It costs $1 billion to make a line that big. And the interest on the $1 billion at this point begins to equal the market value of the power you're stuffing down the line. So using superconductivity to transport electricity is stupid. Okay?
Stupid, you say?
Stupid. S-T-U-P, stupid.
Thank you.
What now?
Diese could solve that after that. Well, find out who is stupid.
The combustion of fossil fuels is connected with another problem. Burning them produces carbon dioxide. An excess amount of this gas in the atmosphere contributes to climate change, the global warming related to human activity. That's a topic that comes up again and again in Lindau. Many of the Nobel Prize winners emphasize how serious the problem is and have called for decisive measures to combat climate change.
What I feel very strongly about this is I feel we don't understand a lot of the climate models. We will be able to understand the climate models in the coming years and decades. But I prefer to take a very epidemiological point of view towards climate change, the way we took that view when there was a suspicion that cancer was caused by smoking, or not all cancers, but if you smoked, you had a higher probability of cancer. And after 10 or 20 years, it became very clear smoking increased the probability of getting cancer, even though we did not have a biological molecular view of how it happened. All right? We may not have a detailed climate model view of what's happening, but we know something is happening if it's correlated with the increase in temperature.
Others have challenged the very existence of the phenomenon. For example, Ivor Guyver. In his presentation in 2012, he declared that a 0.8 degree rise in average temperature in the past 150 years probably had no significance for the climate.
So what does it mean then, this curve here? And in my opinion, it probably nothing. Because, I mean, why does it matter if the temperature is going up 0.8 degrees, the average temperature, if indeed you could measure it? So from 1880 to 2013, the temperatures increased then from 288 degree Kelvin to 288.8 degree Kelvin. It's 0.3%. It's very little. And if it's true, it means to me the temperature has been amazingly stable. I was amazed that the temperature can be so stable.
Predictions of the future are sometimes speculative, often inconvenient, and certainly controversial. Which Nobel laureates are on the right track with their views? The future will tell. Passion, persistence, and inventiveness can turn today's problems into future opportunities, opportunities for great science. And as the laureates always emphasize at the end of their presentations, it's not the old Nobel Prize winners who will be doing it, but the next generation, today's young scientists.
So now it's up to us, and especially up to you, to really do it. Thank you very much.